Hello everyone, my name is Yang Wen. I'm an application engineer at Maxim in CDC Group. Today I'm going to demonstrate this reference design for Xilinx FPGA application. As everyone knows, the size, the cost, the complexity are always issues facing power electronic engineers, especially when it comes to high power multiple output applications. Today, in our reference design, the Maxim's IC, Max 16602, the Max 20790, the Max 77812 is going to demonstrate how we eliminate those issues for high power FPGA applications. So this is Maxim's power tree design for Xilinx Versal AI Core. In this design, there's a single 12-volt input that supplies the power tree that outputs 6 separate rails ranging from 500 milliwatt to 130 watt. So the Maxim 16602 is a multi-phase controller device. The device features a scalable solution that supports up to 16 power stages to cover high current needs. It also works with coupled inductors for faster trend response and reduce the output capacitance. So the Maxim 20790 is a 90 amp single-phase power stage. In this reference design, we have 8 of this device to supply 130 watt output power to Xilinx FPGA. So the combination of the Max 16602 and the Max 20790 Slim devices working together with 4 of the Maxim's 2-phase coupling inductors. So the total solution eliminates the needs for many external components and provides a very compact solution size. So the Max 16491 is a 9 amp step-down regulator. In this reference design, it steps down 12 volt to 5 volt to supply the Maxim 150 or 101 and the Maxim 77812. So the Max 15101 is a 1 amp linear regulator in very small footprint. And the Maxim 77812 is a 5 volt supply to 20 amps 4-phase buck regulator with a very flexible phase configurations. So this is a reference design board. It features 2 banana jacks for the 12 volt input and a socket for the output large current load. And we have the Max 16602 controller located here and input capacitors and 8 of the Maxim 20790 power devices working with 4 of the 2-phase coupling inductors. You can see it's a very small solution. So we have the Maxim 16491 to step down 12 volt to 5 volt and then the Maxim 77812 to supply the low current rails. So we have a connector to PN bus and S-bit interface and the switchers to enable the controller Maxim 16602 here. And on the left hand, there are test points for efficiency measurement, output feedback sense, and some signals like monitoring PMW signals and current sense and temperature sense signals. So this is the Max 16602 using the graphic software to connect the device's PN bus interface. The telemetry data is pulled out continuously and displayed in the graphic user interface. In this case, the output of the device is enabled, and so we can see the read V out, read I out, and the read temperature data updated continuously. So click on the detailed tab for specific device. We can see the command monitor, the command configuration, and the command faults store all those detailed command information. This is the scope shot when enable the maximum 16602 and output ramps up to regulation. And you see the power good asserts after the regulation is reached. Thank you for watching this brief introduction for this reference design. If you would like to learn more on Maxim's product in this reference design, you can visit Maxim's website and download the IC datasheets, as well as contact Maxim's for any more questions.